about this so much, but I just could not leave it until we get this done again. And it's coming up on the exam on Friday. These inverse functions, guys, all I did was the definitions and restricted intervals that we've been talking about, where they chopped off a piece of the graph to make it one-to-one. Okay, that's what all that says right there. Then there's some examples here. Now I'm going to look at a few of these examples with you just to move back into what we were doing on that particular page there. So guys, look down. We're not going to work all of these, but it says for practice, before I do anything else today, was to find the exact value of these expressions. And just at random, I see one that says this. It says inverse cosine negative radical 2 over 2. Now, when you open up the exam on Friday, and you're thinking, Professor, I'm certain of my inverses, first you got to realize or translate what that means for you to find. It's asking for an angle. There's an angle out there whose cosine is negative radical 2 over 2. I'm going to translate it for you. There's an angle theta out there. We'll give you this. We put a comma there. Okay, the one's every down by restriction. Those restrictions are also on the handout. Where should this angle be located? If I'm doing an inverse cosine. From 0 out to pi. Was 0 and pi included? Was it bracket? Okay, so from 0 out to pi. Now, you got to come up with, I was talking yesterday about the unit circle. You got to know this unit circle. And I think I may have said, I'm not going to pass one out to you. You should know that unit circle. Guys, does anyone recognize where you have seen on the unit circle cosine, which is x, equal to a negative radical 2 over 2? Beautiful. So if you say, Professor, I see it correctly or remember it correctly, it's 3 pi over what, 4? And does 3 pi over 4 fit here by restriction? It does, so there's the answer. You're finished. So you have some on the exam that easy. We're just recognition from the unit circle. We'll give it to you. Guys, this is, we'll write this up here. That's 3 pi over 4. Done. There's another one there that I saw also, I should point out. And that's this one. Inverse tan of this. Negative radical 3 over 3. Which means, translate it, there's an angle out there when you take its tangent, you get this, and I'll put a comma here, by restriction. Does anyone remember the restriction now for inverse tan? Negative pi over 2 to pi over 2. Negative pi over 2 up to a positive pi over 2, not inclusive. If you want to think about quadrants, guys, this covers quadrant 1, quadrant 4. Think about negative pi over 2 to a positive pi over 2 on the unit circle. In fact, back to 0 pi that we finished up earlier, you could think of this as covering quadrant 1 and quadrant 2. If you're going from 0 to 180. Now, they're telling me, maybe, there's an angle out there. It's got to be caught here. And when you take its tangent, maybe tougher to find, when you place y over x from the unit circle, you get negative radical 3 over 3. Does anyone think they know what that angle is?
5 pi over 6.
What? Negative pi over 6? Let me do a quick check just for the class here. A negative pi over 6, we're down in quadrant 4 if we move negative pi over 6. So definitely we're in the quadrant. This would fall between negative pi over 2 and a positive pi over 2. Guys, for a quick check, negative pi over 6, if you check the unit circle and know what you're looking at there, were the coordinates help me out here for pi over 6, was it radical 3 over 2 and a negative 1/2 or not? Were those the coordinates? And then I'm asking for what? Tangent, so you place y over x, I'm just doing a little check here. of that, so you can place negative 1/2 over radical 3 over 2. 2's drop out, rationalize, which we should know by now how to do. And you end up with negative radical 3 over 3, and that's what we want. That's a full translation, what they want. Okay, so that's part 1 of that. And let's see if I need to mention anything else here. Number 5 looks unusual on your handout. About number 3. It says inverse tan 4 pi over 5. Why I threw that in there, I don't know, but we'll look at it. Inverse tan. And with that said, translation, there's an angle out there, we think, that might have this as a tangent. That's the translation. Oh boy, this looks strange. And I know by restriction from the previous problem, if this thing works out, the angle I'm looking for is got to fall between these two, quadrant 1, quadrant 4 again. And guys, does anyone see 4 pi over 5 on the unit circle? The first two were easily answered by going back to the unit circle and look at numbers in the unit circle. So what am I doing here? And in fact, is it possible? Give me some thought. Why would I place this on the handout? Anyone think it's possible? Because I'm sure you don't see 4 pi over 5, do you, on the unit circle?
It's possible. 0.
Oh, you say it's possible.
Yeah.
From the unit circle, it's possible.
No.
Now that's what I'm saying. Mr. Park, calling you so much here. Would you please estimate for me, or in fact you might be able to do it all right now, this inverse tan of 4 pi over 5 and see if it's possible. See what angle comes out.
68.
How much?
68.
68 degrees? You got it in degrees?
Mhm.
Okay, I'll put it in degrees. He says it's close to 68 degrees. Guys, is 68 degrees one of those we recognize from the unit circle? No, we recognize what? 30, 60, 45, those types. That's the reason I brought this in there. It's possible. You just use a calculator, so it's out there. Now, number 4. Just thought about that in that conversation. I also have one on the handout that says this, inverse cosine 2. Now tell me a good rationale why, immediately, I know this one's impossible. This one had an answer. This one looked impossible at first, but it does have an answer if you have a calculator. Guys, this one says inverse cosine 2. Can someone tell me quickly, within seconds, you would say, no way, this one is impossible. Phil, go for it.
Isn't it outside the negative 1 to 1?
Absolutely, thank you. The domain's supposed to be what? Caught between negative 1 and what? 1?
Yeah.
You're outside the domain. So this one has no solution. Mr. Park, do me a favor and just try it and see what the calculator says there. Just try inverse cosine 2.
Undefined as a real number.
Undefined?
Yeah.
Absolutely. That's why I brought those in. Okay, guys, of course I'm not going to give you something like this. I'll give you more in alignment with these. We can find these from the unit circle. Okay, part 2. When all this is done, I think these handouts are going to help me and you. Okay, find the exact value of a given expression. Here we go. Got more on the handout. Number 1 in your handout says find this inverse cosine 1/2. Now, there's so many different ways to think about these. First, many students may say, Professor, I can go to the unit circle right now, and I think I can tell you what that is right now. There's an angle out there whose cosine is 1/2, and it's caught between 0 and pi. So guys, could be a possibility directly from the unit circle. Where have you seen the x-coordinate cosine equal to 1/2?
Pi
Was it pi over 6? Or pi over 3? That's pi over 3, isn't it, guys? Not pi over 6, don't confuse those. Now that says now finish it up and find now sine of pi over 3. Well, the sine of pi over 3, is that going to give me the what? Right over 3 over 2? And you're finished. Done. Now, Philip, suppose, because I see some on this handout coming up, suppose you say, Professor, I didn't read that unit circle correctly. I had difficulty with the unit circle. Is there another approach here? Well, there is. On this one, this says the angle has for a cosine, translation, 1/2. By restriction, it's caught between 0 and pi. I could come up with, and Ray, I think you helped me out yesterday, I could come up with an identity that connects these two. I'm trying to find the sign of, and guys, what of the 6 or 7 or 8 identities I gave you guys, which one might be appropriate to use here? Sine squared plus cosine squared is equal to 1. Another way to think about this. And I know cosine is equal to 1/2, so I can write this as sine squared plus 1/2 squared equals 1. And this becomes sine squared. Guys, I see 1/4, we're going to move that over, subtract it, you're going to end up with 3/4. Take a square root. At this point, it's plus minus. Radical 3 over 2. So I see that radical 3 over 2 coming in. Now, is it positive or is it negative? What makes a difference? Now I'm looking for sine. Well, here's my restriction. I'm from 0 to pi, that's what, either quadrant 1 or quadrant 2. And what is sine, the y coordinate, in either one of those quadrants? Is it positive? Is that true, guys? If you think about it, I dropped the negative sign, positive radical 3 over 2, same answers we got earlier. Okay? Just give you an alternative. I know another alternative that I'll use on another problem here. Okay, the next one looks like this on your handout. I think this handout, like I said, is going to help all of us. Number 2, secant inverse tan radical 3. And again, I like to break this down so this says there's an angle out there that if you take its tan, you get this. And by restriction, that angle must fall between negative pi over 2 and a positive pi over 2. I know all these restrictions. Now, I don't know whether a student could come up with from the unit circle, somewhere on the unit circle, I don't know what's possible, to place y over x and you get radical 3. If so, we could use the unit circle to help myself out here. Guys, does anyone think they have an angle out there on the unit circle, directly from the unit circle, that would give me y over x tangent to be a radical 3? Come again. Pi over 3. Let's try pi over 3. Now pi over 3, Rebecca tells me, and I think, guys, the coordinates are what? 1/2 radical 3 over 2 there. And you place y over x from the unit circle, you're going to get radical 3. 2's cancel. So I could do this directly from the unit circle. So guys, inside there is nothing but, she tells me, Professor, it's 60 degrees. I found that one from the unit circle. And then what does it say do on the outside to finish up though? Express the what? Secant of it. And secant is 1 over cosine, or 1 over x, and guys, I see the x there, and that leaves 1/2. With all that thought, 1 over x is that going to come out to be a 2. Follow the rationale? I'm hoping Mr. Apart. Sort of check this one also. Go ahead and just put it in directly as I gave it to them. We thought about it as to what it means for us. Let's see if this original here is merely 2. Secant of inverse tan radical 3. Is it 2?
Yeah, secant arctan over 2.
Yeah, right.
Uh-huh.
Okay. Do it that way. And guys, one more here, just to get all this recapping done. Number 3, I wanna look at this one. Try to find where he is. Good. Cosecant of inverse tan of this. Now I'm thinking to myself, okay, that's why it's written. Guys, this means this. This is what it means, and you're caught between these by restriction. I don't think, I don't know what tan is. Tan is what, y over x? I don't think there's one on the unit circle for this one. Or is there? That when you place y over x, you get 2. I don't think you can. In fact, negative 2. So this one will require some other technique, and you're not going to have a calculator, like Park has. Can anyone give me an idea? Ray? I love what she gave me yesterday, and I used it here on a previous problem. I think I may have to turn to either her method, identities, or I could construct maybe a what, triangle? And use a triangle. So I'm going to show you both methods. We'll use Ray's method first. Guys, this one's not on the unit circle. Can someone come up with a connection? Some type of a connection.
So it's gonna have to be in quadrant 4.
Okay, so we're gonna find out where it is first. It's caught between these two, so this is quadrant 1, quadrant 1, quadrant 4. And Jonathan, you think it's quadrant 4?
Because it's negative.
Thank you. Beautiful thinking. That's what you gotta do.
And so then you can say negative 2 is y and.
Oh, you wanna do a triangle?
Yes.
Beautiful. Let's do it. Let's do it, since he mentioned it. He says, Professor, the location of this angle is in quadrant 4. He says, go ahead and do this, drop the perpendicular always to the x-axis, never the y, and construct a triangle. And he's thinking about theta right here in the corner. And tan is negative 2. Now I do know tan is what? Y over x. So guys, I could, if I'm clever, label this side as negative 2 and this side as 1. That's like y over x. And then I could quickly use c squared is equal to a squared plus b squared, Pythagorean theorem, to find the hypotenuse. And I think we'll end up with right quickly radical 5 here. Jonathan, nice thinking there. Now, the only problem is if I want to read directly from that triangle what the answer might be, it's not considered a unit circle. This right here, we want a 1 here, so if I can read it correctly. Guys, you can modify that right quickly. I think I went through this with you guys. I can divide everything by what? Radical 5? Here, here, there, and now it's a unit circle. The radius is now 1, which I1, which is not like the hypotenuse. Now let's go back to see if I can answer it now. Tan should be y over x. Okay, we got that. But they want cosecant. So guys, cosecant should be what? 1 over y? So if I place 1 over y with what we have here, please tell me, do I end up with looking at something like that? Do we have this set up correctly? Jonathan, is this what you were thinking of?
Up
We're in
until-
quadrant 4.
Up until you divide it by everything by square root of 5.
I just made this a 1, so it looks more like a unit circle. That's the only reason I did that, to change it into a unit circle.
Do you need to do that?
Make this a 1. You don't have to, there's other ways to think of it. In fact, chapter 7 will show us other ways to think of it. Guys, if that's correct, please tell me, do I now end up with this? And I hope there's no mistake. Do we end up with that? Yes or no? Now, Jonathan helps us out there. He says, I'm going to do a sketch, Professor, and draw a triangle and label the sides and do that. Other students may say, no, I'm gonna use Ray's method, but you gotta come up with a connection of identities that may finally connect these two. The one I did earlier, where was it? Back here somewhere. Oh, down here. This one had a nice connection. If I had used identities that I could have used. And this one up here, in fact, I did use identities. Guys, does anyone can think of all those identities, an alternative to find the answer by using identities that may give me a start on doing this? I've got a cosecant, I've got a tan involved. And I don't think they're directly related. I don't think one particular identity directly relates them. Like 1 plus tan squared is equal to what? Secant squared? Is that true? And 1 plus cotangent squared is equal to what? Cosecant squared? Can anyone give me a start that where it might take me to where I want to go? And you may have to use 2 or 3 identities to finally get to it. Any thoughts? Because we're hoping to get the same answer that Jonathan had by using a sketch. Any identities? Anything at all? Sine squared plus cosine squared equal to 1, will that help? 1 plus tan squared is equal to secant squared, you got all your identities. Would that help? Who knows? I may try one of these and have to use it to try another and another until I finally get the answer. Does anyone have one in mind where I can just get a start? Maybe it will not lead me directly to the answer. Anyone have an idea? I've got to find the cosecant of that. So I'm trying to connect cosecant with tan. Go for it, 80.
You take sine squared plus cosine squared is equal to 1, divide everything by sine squared.
Okay, hang on a second.
Okay.
So you're going to start with this one. No problem.
And then,
Hang on now. Right now, Aiden, I don't have anything to put in there right now at this moment for sine, nor do I see a cosine listed here. So what do you plan to do with it?
divide everything by sine, so I can have cosecant at the end replacing 1.
Hang on. We're going to divide this by how much?
Sine.
Sine squared or sine?
Sine squared.
Sine squared. I think we did this in class. It's going to lead us to, I think, another identity that we saw earlier. And guys, this is what? 1 plus, can I call this cotangent squared? And of course, the other side, 1 over sine is cosecant, so this is cosecant squared. Aiden? There, you got the cosecant in there. But you don't quite have the answer yet. All I know right now is tan is -2. Now help me out, if I know tan is -2, what may cotan be? Hey, it's reciprocal. Aren't they reciprocal with one another? Yeah, cotangent. Put it up here. Miriam, are you saying this? They are reciprocals. We had all that listed as identities. If that's true, and this is -2, we know that from the given, then this must be what? -1/2, being squared. If I put that in, Aiden, did you have this in mind?
Yeah.
Okay. Hey guys, if I do the math here, it's 1 plus what? 1/4? Trying to do the math in my head here. 1 plus 1/4, what is it? 5 over 4? Yes. And we're going to do a square root. Right now it's plus minus. And you get that. And Jonathan, I think, already recognized that this angle's down in quadrant 4. So cosecant, which is 1 over sine, since sine's negative down in quadrant 4, this answer has to be negative. And therefore these two match up, even though I use different methods. Is that true? So guys, when you see one of these, I know it's going to take a little thought. But this exam 5 could be a knockout. You're going to be very, very careful with it. That's why I'm taking the time with this handout to get you into it. All this is on the test, these types. Guys, take a close look. That's the last I'll do there. Any concerns there? Okay, now, what else did I do on the handout? Okay, guys, let's flip this over. Now, I noticed in the calculus, this one came from the calculus, next one here. It's at the very top of the page, and it says this. Just add it over here. Express inverse cosine whoa, not that one, hold on. That's not the one from the calc book, this one is. Sine of inverse cosine u. And then they use it in calc later on. I don't know whether Mr. Park and Arena remembers doing something like this back in one of their calc courses, okay? Looks a little different. Aiden, the difference is they gave me a variable, u. They didn't give me a specific number, like my other examples. But I can still deal with it. Guys, I need sine of, this one I need, Ray. I'm not gonna make a sketch for this one. A sketch wouldn't work here. Let's jump right into an identity. That's the one thing they know, an identity that would connect these two. One of the easiest identities out there. What is it? That will connect these. Sine squared plus cosine squared is equal to 1. Has to be one of the easiest. And this tells me that the cosine of the angle is, of all things, not a number. They did it for a reason in calc. It's called u. Now, can I put that u in there as a substitute in my identity? And write this as sine squared theta plus here u squared equals 1. And to solve for sine, if I'm careful, and do a square root, so I'm going to end up at this point, guys, plus minus this at this point. You guys agree? Now I have my plus minus as that answer. And that was done quickly if I recognize the identity. Is that true? Now, please tell me, can I go back and erase one of those signs like I did on the previous problems and say, because it's in this quadrant, Professor, drop the negative sign, it's going to be positive. Or Jonathan says, if it's in this quadrant, maybe it's negative, keep the negative, don't drop it. Can I tell here? I can't tell because I don't know what u is. So we just use plus and minus. We use plus and minus. Unless they give me more detail. They did not give me specific number here to work with. Okay, so that's also on the handout there. Let's see, where am I going here to get through all these handouts? Guys, this is going to be a big, big benefit for you guys. Oh my goodness, this takes me down to 6.3. I'm not going to work every problem, but 6.3. Here we go. Solving trig equations. Let me go on down here, get some space since I'm doing all this. It'll be part 2, I guess part 3. Now, you got to have some of these on the exam on Friday. Solve equations, and I'm going to start out with, Jonathan, I thought something you and Miriam were discussing yesterday, I will point out. For an example, this one. Cosine double theta is equal to 1/2. They want you to solve for theta, and they want you to find every answer you can for theta caught between caught between 0 and 2 pi. And looks like I left this one open. Okay. That was not too bad, but I thought about you when I did this. This is what I would do. It's up to you though. So many different ways to do these. Because wait, Professor, I can tell you this much. I can tell you where I've seen this happen. And I will have to give you something that you do recognize, because on these equations, I'm not gonna allow a calculator. So it must be something you work with from the unit circle. And guys, can anyone tell me, where have you seen on the unit circle, the x coordinate, which is cosine, equal to a 1/2 to begin with? That tells me this, I'm called the argument, must be representing pi over 3. That inside part must be pi over 3, because cosine pi over 3, you guys are telling me from unit circle is 1/2. Now, just in case they want more answers, in other words, more revolutions, to pick up more answers, I'm going to add to this, if they need it, the period number for cosine is 2 pi. And I can do this in number of times, where n is an element of the integers. Make sure you understand the period number for cosine and sine, what makes things repeat. So just in case, put the period number on the end. They call this a general solution. I'll give a name to it, as long as you recognize that you should do that. That's a general solution. Now they want you to solve it. So what you've got to find theta, divide by 2. Clean this up. And guys, if I cleaned up and call this number 1 here, got theta is equal to this much, I think it's pi over 6. The last term on the end, this, what's going to happen with the 2's there? They're going to cancel. And leave me merely what? Pi n. And now you may generate as many answers as they wish. You have a general solution. What might you do? You might say, Professor, I know n is supposed to be an integer. Most students start with 0. You know, one of the smaller integers. Guys, if you put a 0 in there for n, this term drops out and leaves you for a possibility of an answer, pi over 6. By the way, now keep in mind how many answers they want. They want all you can list caught between 0 and 360. And definitely 30 degrees will fit. Maybe I can find another one. Let n be 1. Guys, if I go back and put a 1 right here, in my general solution, I end up with pi over 6 plus pi. Add them up with the common denominator of 6, was that 7 pi over 6? That's another answer. You guys who like degrees, I think that's 210. That would definitely fall between 0 and 360. So I keep listing until I get outside this. I'll try one more. It may take me outside, we'll see. If I put a 2 in there, this becomes 2 pi. Add them up with the common denominator of 6. I think you end up with 13 pi over 6, yes or no? And I think that is, since I see so many 6's here, let's think of that on the end as 12 pi over 6. Is that beyond the interval they gave you? So it's an answer, but they're saying no, they just want the ones caught between 0 and 2 pi. So I have at this point 2 answers. Is it true? Now, hang on. Please tell me, is there another spot on the unit circle where cosine is equal to 1/2 besides the one you guys gave me, pi over 3? Oh, is it 5 pi? Over 3. That's another possibility. Because the professor, why are you considering 2 possibilities? Because this is not an inverse problem. I don't see an inverse notation up there. So I'm not restricted by those restrictions for inverses. So it's open. So I got to consider, yes, on the side here, that 2 theta could be represented besides pi over 3 by pi over 3. And pick up all the answers with that period number. And again, they call that a general solution. Guys, divide by 2, don't mess up here. Division by 2 will give me, don't let me mess up. I think it's 5 pi over 6 plus pi n, where n is an element of the integers. There's my particular, my general solution simplified. True? Now let's try this where I let n be try to come up with an answer. N is equal to 0, let's try 0 first. Put a 0 in there, guys, I end up with theta to be equal to, looks like 5 pi over 6. That's 150 degrees. Will it fit here? Definitely, so I have to accept it. There might be another one, so that n be 1. So the 1 right here, you end up with pi. Combine these two with a common denominator of 6. What am I looking at now? 11 pi over 6. That's a fairly large one though. I think it's like 330 degrees if you wish. But does it still fall between these two? Now I think, Philip, we can try more, but I think that's it for this particular problem. Let me list them first and I'll take the question. Guys, we have 4 particular solutions. Let me try to find where they are. Pi over 6. I don't know what order you place them. We'll place mine in this order. 5 pi over 6. 7 pi over 6. 11 pi over 6. Is that true? And those are my particular solutions for that equation. Now, Jonathan, Miriam, mathematicians. They were saying, Professor, how do I know if I'm going to get 4 answers, or 6 answers, or 8 answers? Well, the method I'm using right now, it depends on, like I have, 2 equations actually to solve. I considered a pi over 3 from the unit circle, and a 5 pi over 3 from the unit circle. Is that true? But, I heard you guys talking about this. Here goes. We'll do it like we do. You think a good way to do this is not get too much involved here. And Phil, what was that question?
Oh yeah, so for the general solution, is it gonna be the theta equals or the 2 theta? The theta equals, right?
The general solution is all of this I blocked off. This is the general solution.
I guess I'm not sure.
It's gotta be written like this. I'll just abbreviate there. These are the particular solutions that we have. Now this is what, Miriam? You guys were talking about this, you and Jonathan. Here we go. Real quick, then just make some sense of it. It's all about this after you guys left. Guys, I like to graph this. Just that. I like to see what cosine double theta looks like. Graphed. Now I'm back into a graphing for a reason. Make a connection here. Guys, we're going to graph it through bounding. Then take your 2 theta and bound it between 0 and 2 pi. If you want to use the bounding. Divide by 2. That now gives me, not let me make a mistake. That. That's true? So the initial is going to be 0, the ending is going to be pi. If I do it through bounding. So we've got 0 here, out here pi. Oh, I love this. I'm glad Miriam, Jonathan, I'm glad you guys heard your conversation. Guys, in graphing, we usually do what next? Because you got a graphing problem tomorrow. We usually divide by 4 to cover 4 quadrants, right? So my period here is pi. The ending, subtract the beginning. That's the period. Take that and divide it by 4. That tells you what the space pi. That's my spacing number, pi over 4. So let's start here and start adding pi over 4. If I do, of course, we're going to end up with pi over 4, 2 pi over 4, 3 pi over 4, and that last one will be 4 pi over 4, which is pi, which I want. That's evenly spaced, as it should be. What else was going on there? No, I don't think I had a coefficient out front, no stretch. We're done. Is that true, guys? I just need to sketch it. No reflections, nothing's flipped over. Just a straightforward graph. If that's true, let's see, the cosine graph. Get me out here. Is that the one that starts up at 1 and comes down? Okay, this one is going to start at 1, comes down. Let's see if I got all this correct here, guys. Hang on. Oh boy. Everything correct so far?
Yeah.
Here it comes down, here it goes down to a -1, we think, back on the axis, back up here, goes so quickly, and one cycle of the graph of that cosine double theta looks something like that. Yes or no? Okay. Now, Philip, I wish, yeah, I sure do wish, hang on, that this had been 0. Solve this equal to 0, I had a 1/2. Then you could read off directly what the answers are. If this had been a 0, guys, right here, now we'll go back to the 1/2 just to point out what these guys were talking about, which I thought was brilliant. Could you, if you graphed it, had the patience to graph it, now that we're equal to 0, this represents 0, the x-axis, could you just read off the answers? Professor, there's an answer here, there's an answer here, is that true? If it were 0, and we'll come back to the 1/2 though. 80,
Yeah.
they said they'll go from 0 out to what?
2 pi.
2 pi. So that means, hold on, they want you to sketch another cycle and label it. So the spacing was pi/4, I think, in this particular one here. So you say, wait, Professor, I need to stretch this out another cycle because this is 180. They want you to go out to 360. Where is it? 0 to 2 pi. So guys, that need to add a pi/4, it's 4 pi/4, it's 5 pi/4, 6 pi/4. Let me erase this. Point out something. 6 pi/4, 7 pi/4, 8 pi/4. Now finally, that's 2 pi. That's where they want me to stop. Miriam, Jonathan had this conversation. If it were equal to 0, right here, we have these two answers already. Now would I pick up, to extend this down to 360, 2 pi, would I pick up 2 more x-intercepts like that? Would I actually pick up, or end up with 4 solutions? Is it true? Yeah. I think it's what you guys are thinking of doing there. Now, I didn't have a 0 there. Far about I had 1/2. Now, can you tell the class what I would have to do to get the answers if I were patient? It was 1/2, if not 0. 0, you could just easily read them on the x-axis. The answers, the x-intercept. What would I have to do to consider 1/2?
Draw a horizontal line.
Ooh, hang on. Where?
Y equals 1/2.
Look at that. He says, Professor, go up to 1/2. They gave you a 1/2. And draw a horizontal line through that graph. This one looks strange. Just a little translation of what's going on here. You guys wouldn't have to go through all this, of course. But I just want to point this out. Like that. Is that true? And then you would have to find the answers for this problem. Are the intersections here, here, and of course on the other cycle that I erased out here, we have 2 more. Guys, this one right here is awfully close to 45, even on my rough sketch. And I think we said it was somewhere, where was it? I think we said one of the answers was what, 30? So it might be that one right there. That's just to the left of 45. Is that true? And another possibility would be right here. I mean, my scale's not, it's not drawing scale here. This one looks like it's just a little bit beyond 135, 3 pi/4. And we've got 5 pi/6. That's 150. Does that make sense? It might be over there to the right of 135. So you can find the answers like that, if you were patient. I thought I'd point that out since I heard you guys talking. Guys, any concerns about this one? Okay, let me see on that handout what else I should do here. Now, I just did this. You know what, guys, don't have to graph this business. I thought the visual might help you see what's going on here. Okay. See what else I have here. Okay, it says solve, guys. Solve a few more. Here comes one I like. Solve this. It's on your handout. 2 sine squared theta subtract 3 sine theta plus 1 is equal to 0. And this was also asking me to solve on this interval. Like your textbook does. Now why might this one be just a little easier? Why does this bring you, what fond memories come back when you look at this one? Let you. And what would you let you be?
Sine theta.
Love it, sine theta. And guys, if I rewrite her help, here goes. She says, Professor, rewrite this as 2u squared, like this. Subtract 3u plus 1 is equal to 0. Now you're back across the street, middle school. Physical factor? I hope it does. 2u, looks like subtract 1, split these up, and with her help, you're going to end up with these values for u. And she told me that u be sine theta, so really you're saying sine theta is equal to 1/2. Sine theta is equal to 1. Now, if on this part of the test Friday, if I hope I don't make a mistake in constructing the test. Miriam, if you get sine theta is equal to 1/3, and Ramsey has already promised you I cannot do that because you don't have a calculator, then that might say, ooh, I've got a mistake somewhere, or Ramsey made a mistake in constructing the test. I've got to give you something that you recognize on this, so you recognize the unit circle. It's not going to be like a 1/3 or some crazy number. The guys, you should recognize this. Can anyone tell me, we might get started here, where have you seen sine, the y coordinate, equal to 1/2? 5 or 6. So theta could be 5 or 6. Now I am going to do this to generate more if they need more. The period number for sine is 2 pi, n number of times, and you have that. I'll come back to it. Is there another spot besides 5 or 6? Was it what, 5 pi over 6? And that's plus, again, that period number. This one, guys, comes out directly. You don't have to do anything to it. Just start letting n be 0, n be 1. I don't think this is going to be very hard because watch what happens. If I let n be a 0 to start out with, integer, that gives me an answer of 30 degrees 5 or 6, which falls between these two, like they want. If I let n be 1, Philip, if I let n be 1, I'm going to end up with 5 or 6 plus 2 pi. Common denominator of 6, was that 13 pi over 6? I think that takes me outside this. How lucky are we? That's the only answer on that side. 5 or 6 is the only one that works. Let's try this one. If I let n be a 0 here, guys, I think this one says theta could be what? 5 pi over 6, 150 degrees, which certainly falls here. And I'll tell you ahead of time, if you try to let n be a 1, you're going to get an angle that falls outside that interval. So in this case, I have only 2 particular solutions, 5 or 6, 5 or 6. Done. Yes? No? Nima, got a question for you. Sometimes when I construct my test, the author of your textbook, he loves 0, 2 pi, 0, 2 pi. You guys are doing your homework. He loves that. You move to a calc class, and they may say, just find the answers caught here. But let me change it. For some reason, they just want not 0 to 2 pi. Your book likes it because it's one revolution. No, your calc instructor may say, no, just give me the answer caught between 0 and 45 degrees. 5 or 4. And then the only answer that would now be acceptable is 5 or 6. So it all depends on this. I'm more than likely to stick with 0 to 2 pi. Your textbook did. any concerns there?
You're not gonna do sine theta equals 1?
Oh, hang on now. You talking about this problem? What about this? Are you talking about this particular problem?
Yeah.
Yeah.
Okay. Oh, okay, hang
So
on.
we have the right side.
Oh, no, I see, I got you. You said there's u is equal to 1.
Yeah.
That's right here.
Yeah.
Okay, I got you. Got it out there, got it. And then you were saying what here, sine theta is equal to 1? That's what you guys are saying. Now, where have you seen sine equal to 1? Only one spot. Was it pi over 2? 90 degrees? Nothing else. If you want to write the general solution, I don't think it's going to help you here. But it looks like this, Jonathan, this is what you're talking about. And yes, that would have to, you would have to add right here, pi over 2 from the other, as part of the answer. Now, I love those. We get to use a quadratic formula or factor, and just think about it. Guys, let me see if I should do anything else before I leave solving trig equations. Yes, I see one staring at me, I should finish up this. Before I move any further. And it looks like this, I think it's the last one in that category there. 1 plus sine is equal to this. Oh, I like this one, we'll close with this. And again, your textbook allows you to go from 0 out to 2 pi. Solve for theta. Now, why might I really like this one? Help me out. Someone tell me why, that's the last one, example in that section. Why might this just be a nice pre-calc type of problem that USC, Stanford, MIT, any of them would show? Why? What's the difference in this one? That's the reason I did that worksheet like I did. What's different in this one? This one took no time. This is nice here, middle school, with the U. Can I do the U here? Sure. Sure. What must I do?
Change the cosine to sine.
Oh, hang on. You're saying that I got two variables going on, sine and cosine. So you're saying maybe change this into what?
Sine squared.
So we get change into what?
1 minus.
Oh, 1 minus sine squared. Now, if I was in class, I said, where did he get that? He's just smart. He's thinking about this. He's thinking about that identity. And he wants a replacement for cosine squared, so he just moves that over. And you have cosine squared is equal to, yes, 1 minus sine squared. And replace cosine squared with that. Now everything's in terms of sine. Now if I cleaned up first though, go back to my blue marker, you end up with 1 plus sine is equal to, I think there was a 2 out front of that. So we're going to 2 minus 2 sine squared theta. I hope I have no mistake. Guys, now I'm into one variable sine. It's a quadratic. You put this thing in nice order. Just move that 2 sine squared over. Be a nice little quadratic. Plus sine. And I think the minus 1 is equal to what? 0. Is that true? I hope so. Now this is one where I think students would tell me now to do the same thing I did over here, to let u be something. And what would you suggest to let u be now? Was it sine theta? And rewrite this now with that u substitution as this. 2u squared plus u minus 1 is equal to 0. Let's hope this factors. I do not want to use quadratic formula. Okay, 2u, it does, thank goodness. It factors. Split this up. end up with 1/2. -1, of course, you're not quite finished, because u is representing sine theta. We got sine theta equals 1/2. Sine theta is equal to a -1. Now guys, without too much detail, let's start listing the solutions that they want or I want between 0 and 2 pi there. Now, where on the unit circle have you seen the sine equal to 1/2? 5/6 is 1. I think there's another spot. Was it 5 pi? Over 6, beautiful. And then where have you seen sine equal to a -1? 3/5/2. And you are finished. Those are your answers. Now, is all this making sense? Geez, is it coming together now? At first, I think some of the students thought all this trig, and all of a sudden in this short session, professor, whoo, it's taking off. It is taking off. I'm trying to make some sense of it. Guys, that section is finished. Miriam, we're getting closer to where we should be. Now, section 6-4. Coming up, and let's see what they're asking us to do there. I have just a few examples, not too many. I've lost track of which part I'm in, I'm all over the board here. I think it's part 3 down here, it's called this part 4. We'll get this section out of the way. We'll be in chapter 7 shortly. Okay, part 4 says establish. Now, Philip, it says establish, don't solve. So these are different. Establish the identity. Now wait, they have, or I have, for an example here, secant theta times sine theta is supposed to be equal to tan theta. You're not solving anything. You're not allowed to move things around or from one side to the other. They're asking you, please look at that and establish, show that that also is an identity. It's not one of the most common ones I've listed for you guys, but it is an identity. The two sides are identical. Does anyone have any way at all to show, not solve, show the two sides are identical?
You could show that second is equal to 1 over cosine.
Change this to 1 over cosine, which it is. Absolutely. And he wants me to leave sine the way it is for right now. And guys, when they ask you to establish, they usually ask you to stay on one side. You can't move from one side to the other, not solving. At this point, he would have sine over cosine. And that's directly tangent. And you're finished. You've established two sides are the same. They're identical. Easily done. Easily done. Thank you. That was done. Part B. Establish. I don't have too many of these down here. Oh, yeah, I've got 3 of these. Guys, let's try this one. Sine theta plus cosine theta. Looks like the entire thing is supposed to be squared. Plus sine theta. Subtract cosine theta. All that's being squared. And all that's supposed to be merely 2. Let me do it like this to show it, not solving. You guys will see on that left-hand side where everything's taking place, and show actually the left-hand side is 2. I like to show it. What do you guys suggest I do first in the attempt to show the two sides are identical? What would you do? Friday. You open the test on Friday, you see this. What are you going to do? I see a hand go up. Yeah, Vanessa.
Wouldn't it be sine squared plus cosine squared, which equals 1?
Oh, I got you. I got you. I see what you're saying. Be careful. Oh, you're almost there. I might, as a student, say the same thing. She said, Professor, that should be sine squared plus cosine squared. Gotta be careful. Because I know I'd do the same thing if I were a student. That really looks like this. A plus B times A plus B. So Vanessa, I'm gonna modify your answer a little bit. This can be, when you expand it, this, sine squared, as you said, but plus what? 2 sine theta cosine theta plus cosine squared theta. You guys agree? That's the way that looks. Now, this one. What I think I'm gonna do, I'm just lined up with the blue one, so we use a different color here. So I'm gonna tell me what sine theta subtract cosine theta is equivalent to.
Sine squared theta.
Sine squared, I heard, I'll put it here, and
Minus 2 sine.
minus, thank you, 2 sine theta cosine theta plus cosine squared, look how cute this is. Those are the 2 squared, simplified, now put them together, and Vanessa, these 2 terms, we left out here, they cancel. So I'm left with 2 sine squared theta, and way down here on the end, plus 2 cosine squared theta. All this taking place on the left-hand side. Now what would you like to do, because you gotta eventually get here. You gotta show it's equal to 2. What would you suggest to do now?
Take the 2 out.
Take the 2 out. And that would leave you this. Which is cute. And that says 2 times, this is one of the fundamental identities. This is 1. And therefore, you got the 2 sides match up. I think of all things for students to do, unless I give you one that's really, really rigorous, is if I give you one of these, you'll know before you walk out whether or not you got it. Because the 2 sides have to match up. And so you make sure the 2 sides match up there. Guys, any concerns there? At all? Okay. Did I have one more there? On the identities. I'm getting a little tired here. Okay. I'm gonna see the one more here. Now, my handout, boy. Can you guys see a secant theta over cosecant? That's what it should be written. Secant theta over cosecant theta. Now, I need some help on this one. And it looks like it's a plus sine theta, if I'm copying this down correctly, over cosine theta. And you're trying to show, well, all that's equal to, by an identity, to tangent theta. Now quickly do this when you see this on the exam Friday. That shows you got stage at one side. Guys, does anyone have an idea what you could do? See hands going up here. Go for it.
Multiply by cosine,
Oh,
everything by cosine.
do it again.
Multiply everything by cosine.
Now, when you say everything, like everything where? Both sides?
Yeah, both sides.
Oh, you can't go to both sides. On an identity, you must stick with one side and show it's identical to the other side. You can't, it's not an equation.
I see.
You cannot do this. It's not an equation, solve an equation. You can't do that.
You can rewrite the first term as 1 over cosine divided by 1 over sine.
I love that. Hang on, hang on, hang on. Perfect. And we'll leave this the way it is.
And that changes to sine over cosine.
Look at this. Now, she's telling me, Professor, if you clean this up, algebra, you're going to end up with what? Sine over cosine. And you gotta keep in mind, you still have also down here another sine over cosine. Now
Sine
guys,
over
could I put those 2 terms together with a common denominator of cosine and have everything over cosine, that's my common denominator, and when you pick these up and add them up, it's 2 sine theta. Which I think, if you take a close look, This gives me merely this, which I want, 2 tan theta. Sine over cosine is tangent. Isn't that cute? Aiden, that's a common mistake when students see this. You cannot do things to both sides. Yeah, not like solving an equation. That's the way I should phrase it. Guys, was that the last one there? Look how fast this is moving. I'm glad I did this handout. We'll be here forever. What section was that, by the way? 6-4? Okay.
But you said sine over cosine equals tangent, and then the other one is sine over
What do
cosine
you mean,
equals
you wanna
tangent.
do this right here?
Did you have to do the bottom part?
Can you go ahead and put that as tangent?
The step part 2, but you just said that each one of those
Oh,
are
I got
tangent.
you, absolutely, perfessor. Like it's in this tan plus tan.
Yeah,
I cannot not just merely said that's 2 tan. Rather than going through that common denominator. Wow, of course you could. Of course you could, absolutely. Guys, connections. That's what this trig is all about. And they love the trig, even when I teach it, I love the trig in the calculus. In Math 7. They love the trig in calculus. Wait till you get there. Because everybody's going to do something else on it that I'm not doing. Some more operations on it. Okay, I'm checking my time here. Now, see, I'm aiming for chapter 7. Aiming. Okay, so I was hoping that these handouts will help me get there. We'll see. And also I gotta mention something else about the quiz. It's coming up tomorrow. I don't want anyone to mess up on that last quiz. Now, I think, let me check, is this handout finished? And that was section, Philip, what section was that, 6-4?
Yes.
Oh, my goodness. My goodness. Here we go. Arena, Mr. Parker, you guys help me out again?